Hi guys, Tony here. Welcome to my channel. Today we're going to be doing an experiment with old watch cases. We have 1,000 grams of gold-filled watch cases. These go for about $3.50 a gram on eBay. They're quite expensive, not including tax and shipping. So today we're going to refine these. Okay, here the first thing that we're going to do is take the watch cases and heat them to redness to get any oils or anything that's going to interfere with the refining process off of them. So I've got the furnace preheated to 650 C. We'll let those go for 15 to 20 minutes. Okay, here I'm adding some sulfuric acid to this bottle so it can be more easily accessed in the dropper. Alright, I'll just adjust the temperature on this furnace a little bit. You want to make sure that you heat all your watch cases or any gold filled material all the way to redness. And I'm going to take my beaker and pre-fill this with a little bit of distilled water. I want to get the level just enough to cover the top of the gold-filled watch cases. It's a little difficult to view from the camera, but these cases are red hot. I gotta clean this place up. It's a little bit of a mess, but it works. Now that we've gotten these watch cases red hot, it's time to put them in the beaker filled with distilled water. We have the water level, you want it just high enough to cover the watch cases for when we start the reaction. This is a large batch of watch cases, so we're going to have to heat it in 2 batches, at least for the size of furnace I have. It's a little bit small. All right, we'll heat the rest of these gold-filled cases up to redness, put them in the beaker, and we'll get the process started of digesting the base metals and acid. Okay, so now we're ready to turn the heat on to these watch cases and get the reaction started. I'm just going to get the fume hood going and clear the fume hood out of all this extra equipment. And then I will place a little device to add nitric acid and add a charge of nitric acid to the beaker to get the reaction started. I'm probably going to add about 150 milliliters of nitric acid to this batch to get it going. And then I will fill up the funnel with 500 milliliters of nitric acid to drip in very slowly at first. You don't want to cause a boil over. It would be a huge mess that you do not want. You can see I have my apparatus set up to start dripping it in. And here is the charge of nitric acid going in. I'm not measuring this exactly. I do measure the amount of nitric acid that goes in by how many of the 1 liter bottles of nitric acid that I use. This is going to take approximately 3,600 milliliters of nitric acid to properly digest all the base metals on these gold-filled watch cases. You want to check that you're dripping the proper amount of nitric acid in at first. You don't want too much. As the base metals are dissolved in the reaction, you can increase the flow. The nitric acid I usually buy comes in the larger bottles. I do get the smaller bottles sometimes, and I end up refilling them with the larger bottles, so it's easier to manage. You can't be pouring the 2.5 liter jugs into these separatory funnels like this. You just end up spilling it everywhere. And usually I set aside the proper amount of nitric acid I'm going to be using beforehand, and of course I do the simple calculation to figure out how much I'm going to need approximately. But it's always good to make sure that there's no reactions continuing to happen when you complete your acid boils. So here we've got a good cloud of nitrogen dioxide forming in the beaker. You want to make sure that if you're going to attempt something like this, that you have some knowledge of what you're doing. These nitrogen dioxide fumes are can be lethal to your health. So you want to make sure that these fumes are taken away from you somehow. Here we're using a fume hood. I've seen people do this outside, but I wouldn't trust that process. Even though I'm using the fume hood, I also wear a acid gas mask the whole time. Here we can see that the acid has already started to incorporate the base metals into solution. They're starting to be digested. Now it's just a matter of adding the nitric acid to the solution as quickly as possible. With this size batch, I'm going to have to empty out the beaker at some point. Here's a time lapse of a few hours of adding and refreshing the solution in the beaker. Again, it's very important to have the fumes vented away from you in this. It's could be lethal if you were breathing those fumes in, or cause serious damage to your health. We have a nice vigorous reaction going here. You don't want to get the level of liquid in your beaker too high, because if it boils over, it'll be a big mess to clean up. Just add small amounts in at a time. Once the base metals have been mostly consumed, you can add your nitric acid more quickly. Here I'm refilling my 1 liter bottles with nitric acid. I don't know if this is the best way to do it, but this is how I make sure I get my measurements correct when I'm doing a batch of gold-filled material. Also, it's much easier to handle your nitric acid in the smaller containers. These big glass jars don't lend themselves to filling your funnel very easily. Now you're going to spend quite a bit of time doing the first step in this process, which is digesting the base metals. Usually I digest the base metals on the first day, and on the second day I do a lot of filtering, and then once the filtering's done, I go to add the foils and the gold powders into the Aqua regia for further processing. Our reaction is getting a little closer to being complete now. At this time you can start adding the nitric acid into the beaker much more quickly, as most of the base metals have been dissolved. And when you are getting almost to the end of the process, you can basically just have the nitric acid free flowing into the beaker. I always have a little mental mark on this size of beaker, which is 4 liters, to where I'm comfortable with letting the solution boil up to before I change out the distilled water and change the solution basically. Okay, so now it's time to pour off some of this acid that's consumed the base metals to make room in the beaker to finish adding the acid to digest the base metals. The solution has basically been allowed to boil until it has stopped reacting and producing fumes. You don't want too much excess nitric acid in these solutions. Plus, you'd just be wasting your acids if they're not consuming the base metals to their full potential. In this step, you want to make sure to dilute these liquids further with distilled water, or else when you go to filter these solutions, it will take an excess amount of time, which you don't want to do. It's basically would be dripping one drop at a time. You definitely want to dilute them down with diluted or distilled water. Alright, so we'll bring in our nitric acid delivery apparatus back in and restart the process over again until we get all the base metals dissolved. I've added some more distilled water to this beaker, and we're going to do the same process we did at the beginning, add a charge of nitric acid to get the reaction going. And then we will drip in nitric acid just as before with our secretory funnel. As you can see, the reaction in the beaker isn't as vigorous with all the bubbling and all when it had more base metals in it. It's basically getting near finished. Here I've drained all the liquid that has come off the reaction into two separate beakers, and I've let them settle out overnight. You want to make sure that you filter all your liquids that come off here. Of course, the second beaker is going to have more of the gold powder and foils in it. The foils are what you're looking for. In this process, I like to siphon off the material in the beakers and try to leave as much sediment as I can in the bottom to speed up the filtering process. And I do cheat a little bit. I store the material in 1 gallon jugs. It is mostly clear. This liquid that's coming off, if you do it correctly, won't really form any more sediment in the bottom of those jugs. I still do filter the liquid just to make sure I get all the solid material out of it. There's a little extra distilled water left in the bottom of this jug, which won't hurt anything. It'll just make your filtering process easier. This is our main beaker full of liquid that contains all of our gold powders and foils. I've left this one sitting overnight, and as I'm draining the liquid out of this one, something seems a little strange. I'm expecting to have quite a bit more foils left over in this beaker after this process, but we basically just have a minute amount of foils and gold powder in the bottom. It almost makes me think that some crackheads broke into the lab and took all the foils. I can't be sure of that, of course, but every other batch of gold-filled material that I've done, especially of this size, has way more gold foils. All right, I'm setting up the filtration apparatus. All right, here I'm taking one of the regular filters and folding it so I can capture all the material when I filtered the gold powders out of the solution. Sure doesn't seem like enough foils from the amount of material I had. Golly. Alright, we've extracted all the gold powders and foils. Now it's time to incinerate them and put them in some Aqua regia. Alright, here I'm adding about 300 milliliters or so of hydrochloric acid. We'll dump our foils into here and then add our nitric to get the Aqua regia started dissolving all the gold. Alright, we've boiled off all the excess nitric in the solution. It's time to filter it and precipitate the gold out with some SMB. The solution is hot, so I'm going to cool it down with some ice cubes and add a little bit of tap water to precipitate any silver that might be in the solution out. You don't want to filter these solutions hot because you'll end up blowing through your filter paper. It's not a huge deal, but you'll have to set everything up again. Alright, we've got our solution coming out nice and clear. It's the second time I believe we filtered it here. Just want to rinse all this down and we'll get it into the beaker and put some SMB in it to precipitate the gold out. I'm just going to test the solution here with a little bit of stannous chloride, make sure that we've precipitated all the gold out of solution. All right, looks like the test is negative, and we're ready to boil this and get rid of all the excess SMB in the liquid, and we'll be ready to wash off the gold powder here in a minute. Now I'm just going to pour off this excess solution off of the gold powder, and I always let this sit for a day or two before I dump it out, because there's always a little bit of gold powder that settles down to the bottom. I've got my gold waste jar here I'm pouring the solution into, and now I'm going to give it a little rinse with some hydrochloric acid and boil. I made a bit of a mistake here. I left the gold boiling in the hydrochloric acid a little bit too long when I went in to get something to eat. Luckily, I don't think we lost any of it there. I didn't see any spilled. Just kind of popped up in the container, and I was able to rinse it back down. Now I'll rinse this several times in water to get rid of all the excess chemicals on the gold powder, and then we'll set up the melt table area and try to see if we can melt a little ingot out of this. The amount of gold powder we got out of this sure doesn't seem like it's too much. We'll see what the yield is after we melt this button up. All right, I'm about to show you the little piece of gold that we recovered from the 1,076 grams of watch cases. Here it is. It ended up being 19.5 grams of gold.